Hello, ladies and gentlemen, and welcome to next episode of What's Up with Startups. This is me, Askar, and today with me is Frank Vergunst, my friend and colleague. We worked together for over a year now, and full disclosure, Alta Group, of who Frank is the CEO, is a client of mine, and I invited Frank here because he is doing a really cool and interesting project in battery chemicals. So, Frank, welcome to the show.
Thank you very much for having me.
Yeah. So, for those who don't know Alta Group, Alta Group has not been particularly, publicly active. Tell us, what do you do and why what you do is important right now?
Yeah. Okay. The Alta Group is a Dutch company. We are based in Gouda, famous for cheese and also famous for many other things, and hopefully also famous for Alta as well. And the Alta Group has several companies, among which one is called Alta Carbon Technologies, and we are really working on a CCU project. And that's because we want to do something about climate change.
New Alta Group has a background in oil and gas, right?
In the previous company I worked for, I started there in '09, so it's already quite some time ago. I was the first process engineer in the oil and gas EPC contractor company, and then worked there for maybe 25 years. In the end, I was the CTO, and I introduced many prototypes into the oil and gas business, which is very difficult because it's a very conservative market, but we managed to do that and keep the clients happy about it.
Okay. So, you gradually came upon developing this new project, developing this special catalyst, and tell which uses carbon to produce certain chemicals. So tell a little bit more about this project. How did it start and what did it do?
So yeah, as an EPC contractor from the oil and gas industry, I was able to carbon capture from natural gas streams. But I also wanted to introduce that to the general industry. And then I started to talk to the people and say, okay, how much does a carbon capture system cost if you want to take out your CO2 from your flue gas, for example? At that time, and it's about 2015, I think the ETS price was 5 or 6 euros per ton. So it was very expensive to install a carbon capture installation if it was not really needed by the government, for example. But then we started to think about, as an entrepreneur, you're always looking for new doors to open. So I made a list of 30 molecules you can make from CO2, and I ranked them a little bit. And then one of the best one was the one we are working on today, which is a cyclic carbonates from CO2. The reason why I did it, because I also felt responsible for the environment, and I wanted to do something to bring something to the world. As people say, leave it better than when you go than when you came, and also take care of your grandchildren.
Okay. So if we would describe this, your technology, and for people outside of the chemical industry or even outside the battery industry, how would you do that?
We developed a catalyst, and a catalyst helps to promote a chemical reaction and to make it more efficient. And we use CO2 as feedstock together with another feedstock. Both of these feedstocks are combined in a reactor in combination with the catalyst, and then we form the cyclic carbonate. And cyclic carbonates are used in batteries, and batteries are becoming more important nowadays. So we think that's going to be a big market for us.
But probably there are already exists like a lot of players in the chemical industry who make those cyclic carbonates. And what made you think that you could take on them?
Yeah. These cyclic carbonates are already produced since the late 50s, from the previous century. And there are producers in the US, but also a lot of producers in China, Asia. But we are the only one who makes them at an ambient pressure and at a low temperature. And we have developed a very selective catalyst, which also allows us to have no byproducts, and that's a big advantage. So our capex cost and opex cost, because we save 80% energy, which is a lot, and it gives us a competitive advantage. to the competition.
Okay, so if I can paraphrase that, you managed to find a way to avoid normal constraints or normal requirements of a chemical production by eliminating the pressure, by eliminating the energy that you need, the temperature. And then you say, okay, I basically make the same product as other making it, but I make it in like 5 times more efficient way.
Yes, exactly.
Okay. And that chemical that I make, I would then sell to companies that would make battery chemicals like or components like electrolyte, right?
Yes, those companies
Okay.
blend the electrolyte before it comes to the battery.
That's quite niche. I mean, that's really very, very focused. And it's just, for me, it just demonstrates that, in battery space, you still have so much innovation available. I mean, people get focused on things like, solid state or dry coating or like new
Sodium.
chemistry. Yeah, sodium ion was all the rage last year. But that's quite easy to grasp, even for a non-technical person like me. But when you go like really upstream, then there's a whole world of how you make all of the chemicals necessary for battery production, which are then mixed at the gigafactories in some particular ratios, temperatures, pressures to get the particular battery. I know that you are almost ready to build your first demo plant that's going to make at least 2,000 tons, I believe, a year.
Yes, it makes cyclic carbonates, but also we have a product named MIOX. MIOX is a solvent which is replacing NMP.
And NMP for our non-battery folks, yeah, NMP is the thing you use to make cathodes, which is the key part of the battery cell.
In battery cells, it's used
Okay.
for cathodes, yeah.
Tell about a little bit about the journey from when you started to work on this innovation and to today. I mean, for how long did it take you? What was the core difficulty during that time?
We established our company in 2019 for the battery solvents, and we were trying to get financing for our project. And at that time, we had a very positive business model. And then suddenly you had the war in Ukraine. And then cheap oil from Russia was imported into China and India. And it was dumped, the products were dumped into Europe. So our business model was destroyed. And then we start thinking about not what can we make from CO2, but what can we make from cyclic carbonates. And MIOX was one of the substances, the solvents you can make from propylene carbonate for cyclic carbonates. And then we start looking into the application. And also there was an application for the battery business. So we said, okay, once we already are focusing on the battery industry, with MIOX we can do the same. But then it's a different application in the battery, but still it is a solvent.
Okay. But that's when you kind of got closer to your commercial goals and closer to the actual demo unit. If you go back before that, so you acquired first a license, then for a different catalyst, then you reworked it, and then you involved leading universities of the Netherlands to help you with that, with continue to develop catalysts.
Okay, yeah, that's before that we did develop the catalyst. At first, we had the catalyst which was from the UK, and we were able to use this catalyst from a university, and we tried to scale it up, and that was not so easy. And then we developed our own catalyst, and we scaled also our own catalyst up to the amounts we required for the demo unit. And that was really a very difficult time because it was difficult to make the catalyst and to find the best chemistry to make this catalyst for a cheap solution. And right now we are able to do it, but it took us maybe 6 or 7 months to do all the tests and do all the reactions. And we partnered with a company from the University of Amsterdam, and they helped us doing that whole procedure.
So you don't have your own laboratories, right? You use laboratories available in University of Amsterdam and University of Delft.
Yeah. We have only a small kitchen in our office and not a laboratory, unfortunately.
Okay. So this is interesting for me because I mean you are not a scientist, you're an engineer, and so you worked all of your life in this EPC projects and oil and gas, and then you say, okay, I want to develop something, from scratch. So you get a scientific team, not even one. I mean, I personally saw two teams working.
Yes.
And what was your? I mean, this is a little bit different organization from what I see. A lot of startup teams, they start from a university and then they develop something, and then they come say, we kind of played around in the lab with this on some grants, and now we have this product. Now we want to try to do it a little bit more. And you went from completely different direction and said, okay, how did you choose the place? I mean, Netherlands is quite big on laboratories, and technical skills and sciences. What was your? I want to go a little bit deeper into this because a good example to show other founders. I mean, how even if you're not a scientist, how you can actually structure your way around it and get really good results. I mean, how you went looking for laboratories? How did you form your science teams?
Yeah. Oh, yeah. First of all, in the oil and gas industry, I also looked for new technologies. And I used to pull these technologies from the science to the market, because I was in the market and I was able to translate the requirements from our clients into projects. So for those projects, I needed sometimes technologies who were developed in a completely different area or even in science. So pulling a project to the market is, to my opinion, the best approach. If you start pushing your project to the market as a scientist, it's very difficult because there are two different languages. I mean, engineers and scientists do not communicate so well in the beginning. You need to learn.
Yeah.
You need to learn each other's language and each other's interests and each other's views to problems. Luckily, we have in our advisory board an emeritus professor, Jacob Moulijn, who is very capable in catalysis engineering from Delft, but he also was previously in the University of Amsterdam. And he had his network in the science. So then we started working on his network, and then we came up with the University of Amsterdam, where there's a very nice spin out. And we used this spin out to do this for us. And they gave us it's contract laboratory. So they exactly did perform the job we wanted to perform then. And we were the owner of the IP, which is also very attractive to us. So we have created a lot of patent families from this cooperation. And since Professor Moulijn was also in Delft, we also worked with some postdocs over there to do some tests in their laboratory. They have a bunker where you can do all kinds of dangerous tests if needed. But for us, it was not so dangerous, but you can do it over there. And we use their laboratory to do the test with our catalyst, and it was very successful. And up to today, we are still testing them.
Okay, so having a advisor was really critical. A really good, well-connected, respected, trusted in science world advisor actually help you to find the right places, teams, and communicate to the teams what you.
It was a coincidence we came to our Professor Moulijn, because at that time I had a colleague, and I asked my colleague, who taught you on the university how to design reactors? And then he said, yeah, that's Professor Moulijn, of course. And then I asked the telephone number, and then I called him and I said, okay, my name is Frank. I have an interesting thing. He said, so we went there every month to his home, and he taught us how to design reactors. And it was close to Scheveningen, and in Scheveningen you can eat nice fish. So after we had finished our lessons, Then we went to the harbor, and then we ate some fish, and then we went back to the office. So it was a very nice time. I have a good remembrance of it.
Nice. Yeah.
So
Well,
it's
it's
really a
not
coincidence, and some things are really coincidences. So you have to pick and choose and follow your instinct. Sometimes it goes also very organic. You do not make a plan and then you follow the plan, but you stick to the plan. Or another type. I'm organic. The evaluating.
okay. But this is interesting because in many other interviews, my conversation with founders and CC people, not many actually say that advisors were that critical to their company. And in your case, it's just, I would say, an eye opener that, okay, if you want to scale up, you want to develop a technology, I mean, getting the right team on your side in science can be, if you have like a really good, respectable advisor on your board, and you have to first go and convince him or her to join your advisory board. But the moment they're there, they that's it. I mean, you basically have a whole scientific team on your side, and you even have like 2 laboratories at your disposal to work on that. But I want to go back now. Yes.
Also, our advisory team. There are a lot of experienced people from the chemical industry in our advisory team. So I worked in an EPC contracting environment in the oil and gas industry. So I can build plants and I can start them up. I can operate them. But being a chemical company is a different thing. Ask people to come into my advisory team to help me where I have a lack of experience.
It is very nice to hear that because I mean, you have tons of experience
Okay, but
on
not
your
all.
belt. I mean, but still, you say, okay, I realize, that this is the gaps I have, so I'm going to pull in advisory board that can help me fill them. Sometimes I just see founders much younger than us, than me, and they, oh no, it's fine, we can manage that. Whether that's not really the case. And I wanted to go back to what you said about pull of technologies and science to the market rather than pushing them, because this is what you were doing in your lifetime, but you're also following up on that logic here in this project, and you've managed to secure letters of intent. Of course, these are not like binding and stuff, but still, it's letters of intent from at least 5 customers. And in total, that would amount for over half of your, if the full of those letters of intent would become contracts, and you would build your full scale plant, that would they would amount for about half of your output. How did you tell us? How did you went about conversations with your potential customers? How did you convince them to sign those?
I first started to look into feedstock suppliers, like the major chemical companies like LyondellBasell, like Dow, like Shell, like Ineos, and I told them about our need of our feedstocks, also the need of and they liked our project because we were really focusing on low carbon footprint, using their CO2, using their chemicals, and also our ambitious plan to increase our capacity gradually over the years. So they gave us letters of intent, and then, okay, that is then the feedstock side and the utilities. And then later on, we focused on the clients. And at first, we looked into the market, who are our direct clients. And then that appeared to be the electrolyte blenders. So they blend the salts with organic liquids and then they put it into a battery. So we made a list of who are these companies in Europe, and then we started to send letters to them and emails to them and try to connect with them. With some of them, we already visited in the very early stage, and some of them at a later stage. By learning by doing and hearing what their requirements are, and most of those blenders are also in a kind of a development in the same industry. So we are all at the same level of development. And they liked our idea that our chemical is green, that we have not much energy required, that we are also competitive. with respect to the existing suppliers from China. And by doing that, by having open discussions like that, I get a lot of information. And then you build also a relationship with those people. And then at a certain moment in time, you build up your network and it becomes bigger and bigger, bigger. That's why you are also part of our network. And then people start to help because they feel they want to help you because you try to be nice to each other. And that's why you help people. If you don't like anybody, then you don't help them. So that's how I did it.
How long did it take you? I mean, from the moment you started to sort of mailing the potential clients to signing LOIs with them?
Well, with some of them within a few months, but some of them with a few years. So at the beginning, we were not really having a lot of information. So they were waiting till we have some kind of maturity into our project before they start taking us seriously. But some of them, the biggest one, I knew them only a few months.
Okay, interesting. So my takeaway would be like for other founders, like don't be afraid to just cold email your potential clients, and you will get a response. But then the journey can be quite long one. Okay. All right. So taking a cue from this finding clients, so you were finding clients, you said the electrolyte blenders who would actually buy your chemical. So that means that you're going like really the hardcore way of building a full manufacturing, well, I would say producer of chemicals with your own capacity plants and so on, rather than taking approach that is more common, I would say, in startup world in science, where you have like deep tech and hardware where people design something and then say, okay, now we're going to license it. So why did you decide to go the hard way rather than go with the licensing?
Yeah, well, yeah, I mean, Alta is an EPC contractor. And we thought at that time, if you're going to license it before we have a demo in operation, it will be very difficult to convince the existing chemical companies that our technology is superior to what is available in the market. So that's why we wanted to build the demo unit first to show that it is possible. And then by building this demo plant and seeing what the output could be and how the market reacted upon our products and our ambitious plans, then suddenly we saw also a commercial advantage and also the business case. So we thought, well, why don't we do it ourselves? We can give licenses anyway as well, but we can do both.
Mhm. Okay, so fine. You did the calculation. So you laid out your demo plant, and then you said, okay, this business looks really sweet, and we want to like take it for ourselves. But then, I mean, this is not even the battery. I mean, battery is quite hard. I mean, it's electrochemistry, but chemical industry is notorious for, you know, permits, safety, supply chains, quality of feedstocks. I mean, so you took you definitely looked at all that when you were designing your demo unit, and when you were thinking, okay, after the demo unit, if we're going to be a real manufacturer or producer of chemicals, then we're going to build next and next and next, bigger and bigger plants, and that's not only like capital intensive, but also, you know, it's dangerous chemicals, so you have to be really careful. And when I know that with your experience as EPC, probably okay, it's like it's normal. But then, what in the process of design, selecting the place, securing feedstock, designing the demo unit, getting permits, getting grid connection, what was the hardest part? Which was the most difficult and most like challenging for you and for your team? And how did you manage it? How did you manage to succeed there?
Yeah. Well, yeah, true that safety was not our concern because we were already experienced in safety in the oil and gas industry. Also, supply chains were not our concern because we had a lot of people interesting to supply our feedstocks. We had a tankage farm as a neighbor on the place we selected. Our neighbor is a tankage farm, and they are connected to the sea, to the river, to the railway. So that was also not a big issue. The only thing which was very difficult was the permit, and that's because we have legislation in the Netherlands, and that was constantly shifting and changing because of nitrogen deposition. Every time we had to fill in a program, and every time, and we do not produce nitrogen ourselves, nitrogen oxides ourselves, but we had to prove that we are not making it. And every time this computer program was edited or we received a new revision, and then we had to give in, I think, 5 times new calculations, proving that it's still zero. So this calculation took maybe 2 to 3 months. So we do that 5 times. You spend a lot of time doing calculations for nothing in principle. And that was very challenging because we wanted to move on and we were kept behind by this permitting procedure.
And that's like local Netherlands, the local Dutch regulation, right? It's not like
Yeah.
EU level regulation.
No, it's not EU level. Yeah, it's maybe somewhere connected, but Netherlands is of course a small country, and we have a lot of activities in the Netherlands. So you have also then a very condensed system. Yeah, I mean, then everybody has his piece of the pie.
Mm.
As then on nitrogen deposition, you have the industry, you have transport, you have farmers. Everybody has nitrogen deposition. So we were really full in the Netherlands with this. So that's why these calculations were very important, and I understand that. But we did not have any emission of nitrogen. So we thought it was a little bit stupid that we had to do these calculations every time.
And what about grid connection? I mean, the discussion now, like in public space, that European grids are over congested. It's hard to. There was even like some, I would say, red herring in the news about like thousands, tens of thousands of companies waiting for capacity. I don't remember the country. I think even Netherlands was more mentioned. Getting a grid connection difficult part for you? Was it, or was it managed quite easily?
Well, it was a lucky chance because we had acquired a quotation from a supplier for electricity in our area. And then they gave us this quotation and we read it and we said, okay, this is interesting. So, but we didn't do anything with it. Then a few weeks later, the announcement came that in our area there was net congestion on electricity. Then we read the quotation and we signed the quotation because then we had a contract and then they couldn't ignore us anymore. So then we had already established this connection. So it's really a lucky chance that we already had this quotation at hand. But this is how projects go. It's also a great deal.
Okay. And that's just final because before we move on, if we zoom out on the European level, I mean, everybody who, every conversation I have about building something in Europe, and people say, oh, it's Europe, it's bureaucracy, it's this, you have so many policies, you have so many reporting. From your perspective, all of the European industrial policy and decarbonization policy, has it on the balance more helped or hindered your project?
Yeah, well, for example, you have CBAM and you have ETS and you have IPSI. I must say that CBAM can help us, but at the moment there's no CBAM on chemicals. So it doesn't help us, but it's also not slowing us down. Same as ETS. We are not an emitter of carbon. We are using carbon. So also that it's good that the system is there to make people aware that emitting carbon is coming to an end at a certain point in time. But if it goes too fast, and that's what you see now, that you have, of course, the existing industry is suffering from these kind of rules. And that is also affecting us. Because if we are losing this existing infrastructure from those big companies, because they go out of the Netherlands or go out of Europe because it's too many rules, too many costs involved, then it's becoming a problem because then a green tech company like us wants to come to the market, but we need that on the back of the big existing chemical companies. And we need to work together. We have to do both. So we have to make them able to do their job and we have to be helped also to bring our technology to the market. So it's not directly, but it's indirectly those rules affecting our company.
Okay. All right, interesting. Because when I started looking into a project, I was expecting that I would see a lot of proof of European, heavyweight and heavy-handed regulation, but in reality, not so much. I would say even we used the rhetoric of CBAM and ETS and all the decarbonization policies to our advantage in some way. They're saying, okay, yeah, that's what's going to happen. This is why the product that's developed is advantageous. So let's switch gears a little bit to construction, because your project is there. You have the project documentation already, permits there, grid connection there, and you yourself and your team are like a total of 70 plus years, right? In oil and gas chemicals EPC. So you're going like with the team which is EPC, and then you have the team which is the scientists who develop the catalysts, which is not usual, I would say, for many startups. You usually have like a scientist or some engineers or like commercial guys like me, but you rarely have an EPC as your core team. What, in your view, are advantages of being an EPC who is a startup at the same time? And what are the disadvantages?
Yeah, well, I mean, yeah, as being an EPC contractor and looking to technologies I want to bring to the market, for me, EPC is something well, I do that all my life. So I know how to do it. We know what the procedures are. We know what calculations you have to make. We know how this market works, how this market is behaving, how this market thinks, and that is a big advantage. So if you bring your own technology to the market, for me, it's not required to go to another EPC contractor. So I can do it myself, which is also at my own cost. There's no profit between the companies. It's just at cost. That makes it in general for the whole project attractive, because the whole project is there that reason is cheaper. So yeah, I'm not a scientist and I will never be a scientist, but I'm a true entrepreneur. So I'm looking to opportunities. And if I find then opportunities which are difficult to find and there's still some development necessary to bring it to the market, then I like to do that. But then I like to guide that also in my mind that it has to be practical in the end and you have to bring it to the market. And that gives guidance to also the scientific colleagues. And that was a really nice thing to do. I told you already before that specifically the language is different from an engineer than from a scientist. If you look to the units we use, like bar or like flow or whatever, they're all different. So
Even that.
before you understand each other, you need to develop a common language and a common understanding about the problem, and that is well, also developing in your project and bringing it to the market is also spending time on that. And that's interesting because right now I know how they think, and for the next time I can do it better.
Now you've been like EPC, and you are now a founder, and a company that could have used services of EPC. It's not necessary for you now, of course, but what advice would you give to founders? Many of them do not own an EPC company. Many of them never did an EPC project, but many are at the stage where, okay, we're going to build a first of a kind demo or for a plant. Should we hire an EPC? I mean, I know companies that were on this podcast, like Atomic, for example. They do a green ammonia in Central America, and they hired an EPC, like big name EPC company. But then there was another company on the podcast, a Geo Energy Solution from Korea, and they built a battery factory with no EPC. Pros and cons every time. You, with your experience, what would you recommend founders who are in this position? Should they look for EPC? Shouldn't they? Or if they do contract an EPC, what kind of things they should really take care of, where they should be most careful?
Yeah. Well, yeah, if you source an EPC contractor, it's really difficult because you have to talk about contracts. And if you talk about contracts, then an EPC contractor says, okay, what are your requirements? And I specifically quote to you according to your requirements. And then you start building your plant. Then suddenly this EPC contractor says, okay, but you forgot to specify this. You forgot to specify that. How do you want to do this? How do you want to do that? And then they tell you how you have to develop your own project. And it is not for nothing. That is at cost. They already gave a contract, but then it's extra money. So it's extra changes to the contract. And those changes are costing you a lot of money. So it's difficult to specify as a startup company, to specify what you really want without knowing what is the plant capable of doing, because you're not an engineer. So the experience you are outsourcing to the same company who is helping you with the EPC contract. So I would advise to startups to take an EPC contractor to help them define the rules and the specifications of the plant, and that you take then another EPC contractor to help you build this plant, so that you have not the conflicting interest.
So you would like to actually do it two stage. So one, I would look for EPC contractor. Say, guys, I want to contract you, but not for like full EPC. I want you to help me develop a project, like more project developer. And by the way, you won't be eligible to participate then in my EPC. Would an EPC company be actually happy about it? Would they actually go for it?
In the oil and gas, you see the same. So you have an EPC contractor at the early stage, and then you have EPC contractor at the project stage, and people start working from the results from the first EPC contractor or engineering companies.
Okay, so you need to bring that expertise earlier to help you actually design the contract, the EPC contract, with all the things for which EPC contractor will then quote you. There's one other thing which you could do after that. Say you did that, you contract an EPC company, and in my experience, we used to hire so-called owner's engineer. So because we have no idea, like as people who order this, we're not engineers. So some people are engineers, but they never actually done that. So they hire an EPC. That was like when I was in wind, and wind was at that time was quite well developed. So you could actually find a person who would be supervising the EPC and helping you in the first place to avoid any mistakes, and to work with you to communicate with the EPC contractor, because I would believe that EPC contractors have their own lingua as well.
Yeah, of course.
Would that make sense from your perspective?
Yeah, that is also a good idea. But nevertheless, if you give the contract to the EPC contractor who's going to build your plant, you need to have a good idea about what you want. If you do not have this upfront, make yourself known upfront to the EPC contractor, you're going to be in trouble. You need to have good specifications before you start. If you start to develop the specifications during the contract, you end up with 20, 30, 40% more cost than originally thought.
Thanks. Okay, thanks, Frank. But now you are not only EPC, so you are a CEO of a scale up, and you're about to build your demo plan. Just give us a little bit of insight in your day to day. I mean, what are the things you spend most of your time on? Like, is it technology development? Is it hiring, fundraising? Is it business development? What is this like? How is your time divided? Where you focus most now at this stage?
Yeah. Well, yeah, originally I'm a chemical engineer by education. So originally, and also there's my experience. At the beginning, I was working on those skills because they were close to my body. So I knew how to do it, and I had my colleagues who were helping me with that and doing that on their own as well. So that is the first instance where you start working on. Then if your company grows, Then you start also to lead the company, to lead the people who work for you, which is again a skill which is very interesting to learn. And I had this already, the skill experience with the previous company. And then you start delegating to your colleagues. So you see that colleagues starts to grow and they do their own thing. They just ask you for advice, but they do not need you to guide them the whole day, which is okay for me. I'm very happy with that. And so then people start asking about, okay, what is your vision? What is your mission of the company? So you have to think about that because then they can see if they are aligned with that or not. So that is how it is gradually going. But at the moment, financing is really taking my time. I mean, that's the thing we still need. The rest is already gone. It's already done and it is finished and it's waiting to the organization is waiting till we can step up to the next step, and that's building the plant. And for that, we need financing. So that takes me my time, but also other people are helping me with that as well. It's again, we do it as a team. We do it together.
Okay. So this demo stage financing is what you're focusing on. And all right, because before I believe that you were bootstrapped and you also had you made very good use of Dutch grants for developing the technology and coming to the stage where you are.
Yeah, yeah. Well, yeah, the grants from the local government, but also from the Dutch government and the EU. And we have brought in our own money as well. And all that together made it possible for us to do this development with all the permits, with the design, with the scale up of the catalyst, with the land, with everything.
How was your experience with the grants? Because the grants are usually come with, strings attached and reporting requirements and, you have to spend, well, of course they're good, they're non-dilutive, don't carry any interest, but you have to pay for that. You usually have to pay for that with your time, your team's time for reporting, for justification and so on. How was your experience in that?
First, we thought, okay, let's hire a company who is doing that for us. And then those companies say, okay, we can help you with that, but you have to pay up front. So there was no guarantee that you're going to get this grants, but you still had to pay all the time they spent on getting this. So then we thought, okay, let's do it ourselves. And that was not the easy way. So then we start reading the documentation and all the requirements, and then we start writing. And then there's a organization from the Netherlands government, from the Ministry of Economic Affairs, that's called RVO, and they help you and advise you also on writing the grant text and how do you do that and how do you bring it to a certain point of quality. And they helped us with that, and it took quite some time before we got that. And then we applied for this grant, and then we were awarded this grant. And then we thought, okay, so we learned it ourselves by doing, but also well, we kept our cost as low as possible. So
Okay,
it's very
that's nice.
helpful that this organization is helping you, and they only do that till you apply for a grant, because then they start looking into your application and then they don't give any advice anymore.
Okay, but that's still nice to have. I mean, maybe if you share me the website link to that organization, we could just put it in the show notes for people who are in the Netherlands. If they're looking for something similar, so they could also take advantage of that if they didn't know about it. Okay, so well, it was really interesting discussion. I mean, especially like about looking at EPC from two sides and looking at how you the challenges of securing the land and getting the permits right. Just before we conclude, there's a few questions I usually ask all my guests, and the first one is: if you looking back, I mean, you already been at it for many years. Like you said, 2019, you set up the company. You worked on the catalysts. It's now 2026. If you would do it again, what would you do differently, if anything?
Well, the steps will be the same. So I would do the steps exactly the same as I did before, but I would do them more in parallel. Right now, I did them one after each other. But now I know what the whole process is to come to this project, and then I could already manage the process to do it parallel, because then you save time. Now it was slow, to my opinion.
Give an example, like what would you do in parallel, for example?
Well, the complete design of the plant, all the documentation, all the drawings, we did that in parallel. But for example, for the permit, and then we start looking to financing people, but we could have done it together, and also the grants we
Mm,
could do it together. So all these things we did after each other, and then financing people said, "Okay, do you have a permit?" And then we said, "No." "Okay, we think we will get this permit during the project." And then they said, "No, you know, you have to do it up front." That's why.
okay.
So if we can save time for sure if we do it things parallel. Because right now, sometimes I have the feeling I'm with my foot on the pedal of giving full gas, and on the other hand, I have somebody who's braking constantly. So it's, well, we manage,
Wow.
but it's not always easy.
Yeah. And what would do you have any advice that you could give to people who are just starting on the journey? So what they should look out for?
I think I've put in my money in the project myself. By the time I was at a certain stage, my money was already spent. So equity is really something which is you have to secure upfront, because if you don't have any equity anymore, then your company goes dead. So that's a main important thing which is required. One other advice is stay focused. You have your vision, you have your view, you have your horizon, you have pointed where you wanted to go. So stay focused, keep on going there. Look also to the market, and not try to push to the market, but try to find somebody who's pulling your technology to the market.
That's been like the red line through our conversation, that you can find either pull yourself or find someone to pull you. That's yeah. I would say yeah. It's because I've seen both, and I would fully agree with you. That you have a pull from the market that's just makes things much more easier. Okay. Well, thanks very much, Frank. It was a really interesting conversation for me, and I think for the people listening too. So I wish you all the best
But
and luck with your demo plans, and I'll do on my side as well everything I can to make it happen.
I know you're a good help, and thank you very much for this conversation. It was nice. It is my first podcast, so hopefully the next podcast will be also good as well. And I liked it a lot. Thanks very much,
Thank
Emin,
you.
guiding me through this.
Thank you. Thank you, Frank.
Okay,
Bye bye.
bye bye for now.